Okay guys, so we're going to look at power functions and function operations. I'm going to try to do it this way, see if this is better than you guys watching the back of my hand. Okay, so hopefully maybe you'll get a little bit more out of it this way. I don't know. We'll give it a shot, see how it works. Alright, so we're looking at operations on functions to start. Okay, operations on functions. And for all of these, okay, you want to let F and G, let F and G be any two functions. Okay, I'm going to give you some of these properties and I'll give you some examples. Okay. There's nothing that they hold any kind of power. We have talked in the past how f of x is another way of just saying y. Okay, so the fact that these are different letters just means that they're different functions. Okay, so here are going to be the properties. I'm going to put the properties. X is equal to x plus 1. So for all of these, we're going to talk about that. I want to make sure I'm still in the video. Yeah, still barely. That's about where my cutoff is. Okay, so in the first function, they want you to add both of those. Okay, so we're going to add, and then we're also going to talk about the domain for each of these. Okay, and domain are numbers that you can plug into the function. So let's take a look. You want to add the two functions. So that means that h of x is equal to, well, what's f of x? F of x is 2x. And what's g of x? G of x is x plus 1. So it is as easy as it looks. We just add the two of them together. So 2x plus x is 3x, so I get 3x plus 1. Okay? Then we talk about the domain. Okay, we've talked about domain in this class. We've talked about it in other classes. Domain, and I guess I'll put the domain over here. We'll put this thing up here. Domain refers to input values, okay, or values you plug in for x. So sometimes you don't have any restrictions, and sometimes you do. Okay, if you have a square root, there's restrictions. You can't have negative numbers under there. If you have a fraction, okay, you can't have 0 on the bottom of a fraction. So sometimes, again, you'll have all real numbers, but sometimes you have restrictions. So when you have operations on functions, you look at the domain of each of them, okay, and the domain for the sum of the two has to be the domain for both. Okay, so if let's say one of them is x is greater or equal to 0, the other one's all real numbers, then when you combine them, it has to be x is greater or equal to 0. It's like the path of least resistance. So if I look here, the domain for f is all real numbers. The domain for g is all real numbers. So when I combine them, my domain is going to be all real numbers. There's a symbol like this, an R with two lines like that, that also means all real numbers. You could also call it negative infinity to infinity. That's another way of saying all real numbers. So you could say it that's one way, that's a second way, that's a third way. That's probably the most sophisticated way. When you get to pre-calculus and stuff, they're going to want you to list it that way. So addition The moral of the story here is you take one function, you add it to the other. That's it. Okay, so let's talk about subtraction. So with subtraction, we're going to say h of x equals, now I could put this in any order that I wanted to, it doesn't matter, it just would be how you subtract it, just like the rules of algebra. So f of x is 2x minus g of x is x plus 1. Make sure that you put that in parentheses. Okay, you have to have that negative distribute, it has to distribute. So this is going to be equal to 2x minus x minus 1. So it looks like I get x minus 1. That's the value of subtraction. And then we're going to talk about our domain. Well, we already talked about it with addition. Subtraction is really no different. Okay? The domain of f is all real numbers. The domain is g of all real numbers. So my domain here is going to be all real numbers. Okay? So as you can imagine, the next one's going to be multiplication. Okay, so for multiplication, we're going to say that h of x is equal to f of x times g of x. So let's plug that stuff in. Again, our functions over here, 2x and x plus 1. So this is going to be 2x times parentheses x plus 1. Distribute, 2x times x is going to be 2x squared, and 2x times 1 is going to be 2x. Okay? So, what do we have? Well, let's talk about our domain. Okay, again, domain is all real numbers. Domain is all real numbers. When I multiply it, it's still going to be all real numbers. I can write it like that. I could write it like this. Or words, all real numbers. Division going to be a little different. Okay, division. So, division will say that h of x is equal to, I don't know, which one do we want to put on top? Let's make it f of x over g of x. F of x over g of x. So we plug in our f of x. That's going to be 2x over g of x is x plus 1. Now I look and I want to talk about my domain. But when I talk about my domain here, it's important to note that we have a fraction. The fraction is going to be different. Okay? This is technically all real numbers. This is technically all real numbers. But when I look at my fraction here, I know that it can't be negative 1. So I could write it this a bunch of ways. X cannot be negative 1. I could say all real numbers except negative 1. And then the most sophisticated way to say that would be negative infinity to negative 1 with a parenthesis. The parenthesis says that I don't include that. Union with negative 1 to infinity. Okay, and again, I'm not going to require you to write it that way, but it's good to see it because you are going to have to do that in the future. Okay? Does that make sense to everybody? I hope so. I hope so. Okay, so let me give you guys one to try. So I'm going to erase the f of x and g of x over here. And I'm going to make f of x equal to, let's see, what do I want to do? I don't know. Let's make this x squared. And let's make, you know what, I'm going to do this. Let's make that x plus 3, and then let's make g of x squared. Okay? And I want you guys to go through and do the same thing that I just did for all of these. And then we'll do another example. Okay, this is kind of an easy example for you. So pause the video. Okay, pause the video and give that one a shot, and then we'll put the answers up and see how you guys do. All right, we're back. We are back. All right, so the first one, we want to add the two together. Well, f of x is x plus 3. You want to add that to g of x, which is x squared. So I guess we can put it in the right order. X squared plus X plus 3. Let's look at our domain. The domain for F is all real numbers. The domain for G is all real numbers. We don't have any fractions. We don't have any square roots. So my domain is going to be all real numbers. Let's look at the subtraction one. F of X minus G of X. So that's going to be X plus 3 minus X squared. So it looks like I have negative X squared plus X plus 3. Again, my domain for X is all real numbers, for F is all real numbers, for G is all real numbers. I don't have any fractions here, so we're talking all real numbers for my domain. We go up here for multiplication. F of X, that's X plus 3, times X squared. So that's going to be X cubed plus 3X squared. Domain, all real numbers. Domain, all real numbers. Domain, all real numbers. Division. Okay, let's see if this one's going to be any different. This is going to be X plus 3 divided by X squared. Now, you don't have to do any division here. You can leave it like this. Even if this said X squared at the top and X plus 3. For now, you guys can leave it that way. Now, domain, all real numbers, except we have a fraction there, and I can't have a 0 in the denominator. So I could say that X is not 0. I could say all real numbers except for 0, or I could do that parentheses where I go negative infinity to 0, union with, union means like adding with, 0 to infinity. Okay, and I'm not going to require that notation, but again, I want to say that you've seen it before. So when you go to pre-calculus, it's easy for you. Okay? All right. Let's try another one. We'll do this one together. So let's erase this. You guys can see I don't have the black markers. All right, f of x equals 2x to the 1/2. So we're going to do this just for adding and subtracting, and then we'll do one for a different one for multiplication and division. So f of x equals 2x to the 1/2, and then negative 6x to the 1/2. Okay? And so they want me to add and subtract these first. So another way you can think of this is, if you wanted to, you could think of this as 2 root x, and then this would be negative 6 root x. I don't know if that helps or not. It helps me to look at it that way. So I'm going to take f of x, which is 2 root x, and add g of x. That's negative 6 root x. So when I add those together, I'm going to get negative 4 root x. Now, my domain. Think of this, when you have a square root sign, what can you have? Can you have positives? Can you have negatives? Can you have 0? We can have 0. We can have positives. We cannot have negatives. So my domain would be x is greater than or equal to 0, or you could say 0 with a bracket, which means it includes 0 to infinity. Okay, sometimes they'll say non-negative, or non-negative real numbers, another way to say it. Okay, let's do the subtraction one. So the subtraction one is going to be 2 root x, then it's minus g of x, that's going to be minus negative 6 root x. So those two negatives are going to make a positive, and we get 8 root x. My domain is going to be the same thing. Okay, we can't have a negative underneath there, so we're going to say x is greater than or equal to 0, or 0 to infinity with a bracket around the 0 and a parentheses around the infinity. All right, so let's look at multiplication and division. I'm going to say that f of x equals 3x, and g of x is equal to x to the 1/4. So again, sometimes with those fractional exponents, what I will do is I will rewrite them, and I'll make it the 4th root of x, just so it's easier for me to look at and evaluate. So, multiplying, I'm going to leave it this way. Okay, but I know that that's also equal to that, and sometimes it helps with domain. So this is going to be 3x times x to the 1/4. Well, this is understood to be 1. 3 times 1 is 3. X times x to the 1/4. In order to combine these, okay, when we're multiplying, we want to add the exponents. So it might help to write this as 4 over 4, so it has the same denominator. It's equal to 1. Okay, it's the same thing. 4 over 4 plus 1 over 4 is 5 over 4. So we get 3x to the 5/4 power. Don't write it as 1 and 1/4 power. We don't usually write mixed numbers for exponents. Now, let's talk about our domain. We erase the domain first. So, for this one, it can be all real numbers. For this one, it has to be greater than or equal to 0. So when I'm talking about the combination of them, my domain, it has to be the same for both, okay? So it's going to be x is greater than or equal to 0. All right? Division. F of x goes in the top. 3x. G of x goes in the bottom. X to the 1/4. Now, again, I'm going to make this 4 over 4. So 3 divided by 1 is going to be 3. X to the 4/4 divided by x to the 1/4. I subtract my exponents. I get x to the 3/4. Okay, and again, we have to consider our domain for this. Okay, and when I look at it, I have to think about both of these. Okay, I'm thinking about both of these. So again, this one's all real numbers. This one is positive. X is greater than or equal to 0. However, we have a fraction. We have this down here, and this can never be 0. So instead of saying x is greater than or equal to 0, I can't include 0 any longer. So you might call it x is greater than 0. Okay, you're going to say, well, that's not the final answer. It doesn't matter. When they write it as f over g, you can't have a 0 on the bottom. Okay, so we would have to say x is greater than 0. You can write it this way as well. Okay? So that's our operations on functions. Okay, operations on functions. So now we have to do what's called composition of functions. Okay? Composition of functions. And let's see. Look at this. The board was perfectly clean when I started. Maybe I can use the color markers in the video. You guys, you'll still see it. And on the live video, you can only see black. All right, the composition of two functions. So, composition of two functions. Okay? So, it looks something like this. We'll start off with some easy ones. Let's say that f of x equals 3x. We'll use some of the problems for the last time. And g of x equals x squared. And they want to find f of g of x. So what we have to do here is we have to do a lot of substituting, okay? We have to do a lot of substituting. So what that means is I want to find f of g of x. Now, if I told you that f of x was 3x, okay, I'll do this over here. If I said f of x was 3x, and I said, okay, I want you to find f of 2, what would you do? Well, whatever's in parentheses we multiply by 3, so this would be 3 times 2, or 6. If I said f of negative 1, what would you do? Wherever you see an x, you multiply by 3, so this would be 3 times negative 1, which is negative 3. So if I told you to find f of a, again, the rule here says whatever's in parentheses I multiply by 3, so this is going to be 3 times a. So remember that. I want to find f of g of x. Well, what's g of x? G of x is x squared. So I take out the g of x, and I replace it with x squared. So I want to find